Everyone, welcome to this video. This question is asked in NEET. Which of the following is aromatic in nature? Right? They have given options A, B, this is one C, and this one D. We have to tell which is aromatic. So let us discuss what is aromatic. So to a molecule becomes aromatic only when it satisfies these four conditions. One is it should be cyclic. Second one is it should be planar. Planar means its hybridization should be always sp2 or sp, right? Only when it will be planar. The third condition is it should have conjugation. What is this conjugation? This conjugation is nothing but this one. Always we say double bond, single bond, double bond, single bond, double bond. We call it as conjugation. But here conjugation should be in cyclic only, because the first condition is cyclic, right? So here if I have benzene ring, it is aromatic. Why it is aromatic? See, it is cyclic, and here double bond, single bond is there. Next double bond comes, again single bond, then double bond comes. So it is aromatic. So this is, we call it as conjugation of pi electrons. We call it as what? Conjugation of pi electrons we call it as, right? So it should have, third condition is conjugation of pi electrons, and the fourth condition one is this. The fourth condition is it should satisfy Huckel's rule. What it should satisfy? Huckel's rule. What is this Huckel's rule? Huckel's rule is nothing but 4n plus 2 pi electrons. Pi electrons should be 4n plus 2 pi electrons, right? So what is this 4n plus 2 pi electrons? See, if n is equal to 1, how many pi electrons will be there? Just check it. N is equal to 1, 4 ones are 4, 4 plus 2, 6 pi electrons, right? Similarly, n is equal to 2, how many? 4 2s are 8, 8 plus 2, 10 pi electrons. So this is the rule they will tell about, right? So let us see the given compounds. Let us check. The first compound is this one, A, B, C, D, right? So let us discuss one by one. So see, I have this one. This has got pi bond, and this is plus. So whether it is cyclic, yes, cyclic is there, it is cyclic, and it has got conjugation, yes, conjugation is there. So see, conjugation, if I want to show with the other color, so here I can show it. So here pi bond is there, followed by single bond plus electron deficient, so it can conjugate. Again single bond, again pi bond. So conjugation means double bond, single bond plus can be there, double bond, single bond negative can be there, double bond, single bond, lone pairs can be there, double bond, single bond, double bond, anything can be there. Lone pairs means here it will be like double bond, single bond, NH2 like groups are there, right? So they can conjugate, right? Are you getting? If I wanna write the structure, correct structure, it is like this one. NH2 is there, lone pairs attached to single bond, double bond, so it can easily conjugate. So this is, we call it as conjugation, right? So it has got conjugation, and it is planar. All hybridization, if you check, it is also sp2, it is also sp2. So it is what? Everything, this is also sp2, so it is planar in structure. So it is, as it is satisfying all three conditions. Fourth condition, so 4n plus 2. So here if I put n is equal to 0, what I will get? I will get 2 pi electrons. What I will get? 2 pi electrons. So in this cyclic structure, if you count the pi electrons, so this is the only pi electron I have, right? Pi bond we call it as pi electron. One pi bond means 2 electrons, so it has got 2 pi electron. So it is what? Aromatic. So this compound is aromatic. Other three, let us see. So other three were like this, right? Other three, let me write it here. The other three is, one is this one. So this is also what? All are sp2, cyclic, planar, right? All are cyclic, sp2, planar. But the thing is, here if you count, this is also pi electron I can see, and this is also pi electron. So one pi bond means 2 electron, one lone pair means 2 electron. Total 4 pi electrons are there, which is not the Huckel's rule. That's it. It is not satisfy this 4n plus 2, right? If n is equal to 0, I will get 2 pi. If n is equal to 1, I will get 6 pi. So it won't satisfy. So this is not aromatic, right? And other one is this structure, right? So this structure, if I see, it is like this. Here conjugation is there, right? It is cyclic, yeah, cyclic it is there. Conjugation is there. Conjugation means double bond, single bond, double bond, single bond, double bond, single bond, and double bond. So conjugation is there, no doubt. Pi electrons are there, and if I count the pi electrons, it is 2 4 6 8. This also doesn't satisfy Huckel's rule. And one more thing is, it is non-planar. This has got bucket structure, we call it as bucket like structure, right? This is non-planar. Because of this is non-planar, so it is not aromatic. It comes under non-aromatic compound, whereas this above one, this comes under anti-aromatic compound, right? So let me check one more compound. Which compound I have got? I got this one more compound, that is last compound, this one. Yeah, let me draw it again here. So here the last compound they have given this one, double bond CH2 here, here double bond CH2 here. So here also conjugation is double bond, this is double bond, single bond, double bond, single bond, double bond. So conjugation is there, no doubt. It is cyclic, but conjugation is in non-planar, means conjugation is like a straight chain, double bond, single bond, double bond, single bond, double bond. It is like similar to this one conjugation, right? So it is not aromatic, not aromatic. And these hybridization, if you check this carbon, let me draw it here so that it will be clear to you. If you see these hybridizations, it is sp3, which is non-planar, which is sp3, because sp3 means tetrahedral geometry or tetrahedral shape. So these are non-planar. As they are non-planar, this is not aromatic. So the answer, for our answer is this one. A is aromatic, whereas B is anti-aromatic. If you know about anti-aromatic, you can tell this is non-aromatic, this is non-aromatic, and this D is non-aromatic, right? So thank you.